The overall goal of this protocol is to fabricate degradable versions of thermoresponsive hydrogels with controlled length scales and geometries.
This method can help address key challenges in the area of biomedical materials, such as facilitating long-term, minimally invasive local drug delivery, creating responsive scaffolds for tissue engineering, or designing targeted nanotherapeutics.
The main advantage of our technique is a rapid, reversible hydrazone chemistry, which allows us to control the size and shape of the degradable hydrogels by changing the polymer precursor mixing geometry.
This flexibility lets us fabricate bulk gels, microgels, nanogels, and nanofibers all with the same starting materials.
First, prepare about 2 milliliters each of hydrazide and aldehyde functionalized thermoresponsive precursor polymer solutions with concentrations between 5 and 40% by weight in 10 millimolar phosphate buffered saline. Use single-barrel syringes to load the precursor polymer solutions into separate barrels of a 2.5 milliliter 1-to-1 double-barrel syringe. Next, connect a 1.5-inch static mixer to a 2.5 milliliter 1-to-1 double-barrel syringe. If desired, attach an 18-gauge or 20-gauge 1.5-inch needle to the static mixer. Then, cut from a soft silicone rubber sheet of the desired thickness a piece about the size of a standard microscope slide. Use a punch set to punch at least one hole of the desired shape into the silicone rubber sheet. Place this silicone rubber mold on a clean glass slide, ensuring that all holes are backed by the glass. Gently press the mold against